Here is a question that appeared in the CBSE board exams in 2024. Let us read this question. An infinite straight conductor is kept along the x axis, basically the x axis, and carries a current I. So what is the direction of the current? It is given that it is along x axis. So that means the current is flowing from the negative x axis to the positive x axis. So it's flowing in this direction. Okay. So current is I flowing in this direction. A charge Q at point P, which is 0, r. So 0, r is obviously on the y axis, right there. So it starts moving with a velocity v equal to v naught j cap. So v naught j cap will basically be upwards like that, right? So as shown in this figure, find the direction and magnitude of the force initially experienced by the charge. So basically, when the charge is here and starts moving upwards like that, we want to find the force acting on it. So how do we do that? For that, I need to know the magnetic field at this location, magnetic field due to an infinitely long wire. We know that formula for that, right? So magnetic field due to an infinite straight wire is B equal to mu naught I by 2 pi r. So we know that formula. And of course, we know the magnetic force on a moving charge, right? This is a moving charge. So once I know the magnetic field there, then I can use F equal to Q V cross B. So I need to use both of these formulas. So first, this wire is carrying current like that. So I can apply this mu naught I by 2 pi r. But for that, I need the right hand thumb rule. So I'm going to grab this wire like this with my thumb pointing in the direction of the current. So if I did that like this, right? So the fingers tell you the direction of the magnetic field, right? So the magnetic field lines, they're going to curl around like this. So that means here, right, you can see that it is coming out of the board, coming out of the board. So everywhere here, the magnetic field is coming out of the board. What about down in this region? Well, there it is going into the board. There it is going into the board. I'm not interested in that. I'm only interested here. And here you can see that these magnetic field lines, they are all coming out of the board. So magnetic field is coming towards you, Okay, velocity is this way, magnetic field is that way. So starting from V, you have to go towards B. So V cross B, you know it's pointing that way. The force is going to be pointing that way. But let us use some vectors and solve this problem. So first, I'm going to find the magnetic field at that location. What is this distance? This distance is r. So I can write mu naught I by 2 pi r. So the magnetic field at P is mu naught I by 2 pi r. In what direction? Coming out towards you, x-axis, y-axis, right? X cross y, that will give you the z-axis. So that means it's going to be this way, k cap. So that is the direction of the magnetic field. So mu naught I by 2 pi r, k cap. Mu naught I by 2 pi r, k cap. Okay, so that is the magnetic field. Now I'm going to use this formula to find out what is the force acting on this particle. So what will be the force? The force experienced by the charge F is Q times V cross B. What is V? V is V naught J cap cross B. Mu naught I by 2 pi r K cap. So of course all these, they're just numbers, we can take it out. And we have this vector J cap cross K cap. J cap cross K cap is I cap. J cap cross K cap, right? J cap cross K cap. J cap cross K cap is I cap. So we can get that. And so basically I'll get Q V naught mu naught I by 2 pi r I cap, right? So Q times mu naught V naught I by 2 pi r, J cross K is I cap. So we get that as the answer. Okay. Of course, you can also figure this out by saying V is this way and magnetic field is this way. So V cross B must point like that. And that direction is, of course, I cap direction. So once you get the magnitude QVB, it's all perpendicular. V and B, they are perpendicular. So V cross B, V into B into sine of the angle between them. That angle is, of course, 90 degrees. So we just write V into B. The direction is what we are getting out of this. So here we've used plain vectors to find the answer. You could have also done directly V cross B by looking at the right hand thumb rule. Either way, you're going to end up getting that F equal to Q mu naught V naught I by 2 pi r acting in the positive x-axis direction.